Sorry. Okay. So here we go. We're going to do 3 choices. So I always start here and I go first, second, third. This is just how I do it. And I go, okay, I could get white. Then I could get a black or a white, black or a white, black or a white, black or a white. And since it's with replacement, the probability of getting a white is always 4 out of 10, or 0.4. I'm just going to put it on that line. And the probability of getting a black is always 0.6. So far, so good? Okay, so now I'm going to write down epsilon. I'm going to write down the set. Okay, the outcomes. So I can get this, or this, or this. Are you okay at this? All right, so I just go along the branches. All right, okay. And down here. Okay. So I have 1, 2, 3, 4, 5, 6, 7, 8, 8. And I'm looking for the ones where I have a white ball being drawn once. All right? So that's this one, that one, that one. That looks like that's it. Okay, so to do that, I do, okay, well, 0.6 times 0.6 times 0.4. Is that right? Black, black, white. Okay. And so 0.6 times 0.6 times 0.4. An enormous amount of calculator stuff, so make sure you get that out. Is 0.144. Is everybody okay? And I've got 3 of those. Are all 3 of those the same? Yeah. Okay, so the probability of getting one white ball in this situation is 0.144. Okay? Now, if I want, that's the answer to this question. Yeah? Oh, yeah. Sorry. 3 of those. I meant to write that. I was thinking of something else already, Mina. So I need 3 of those, yeah? 0.432. All right. Now, if I wanted to do a probability distribution of this whole setup, and I wanted to say, okay, well, what's the probability? I would write this. I'd say, okay, I've got my x's here, and I could either get 0 white balls, or 1 white ball, or 2 white balls, or 3 white balls. Is that right? Those are my options. Now, in this little thing, a lot of different things can be drawn. Okay, and this is why probability will drive you crazy. Okay, Ms. Fidel says, like that. I'm like, just take a breath. It's kind of like when you first do f of x. Why don't you just use y? But then all of a sudden f of x is nothing, right? It just is with you. Okay, so inside of here, it can say p of x. It could say that. And they're talking about, the function of x each time what's there. It could say, or it could go PR probably. It could go PR of big X equal to little x. Okay, it could have that. Don't get too stuffed about it. It's a probability distribution table. It's not going to trick you into it being some weird thing, okay? Now, if I wanted to do a probability distribution of this whole setup, and I wanted to say, okay, well, what's the probability of getting one white ball in this situation? Okay, so inside of here, it can say p of x. Okay, it could have that. And they're talking about, the function of x each time what's there. It could say, or it could go PR of big X equal to little x. Okay, it could have that. Don't get too stuffed about it. It's a probability distribution table. It's not going to trick you into it being some weird thing, okay? Anyway, you could see lots of different things there. I reckon that this is probably the most common, but this book we're using does this, because it's a little bit easier, I think. Okay, so we will... Oh, I didn't want to do that. Yeah, I will. What the heck? Let's do that. I wanted to do something else. So in our table, we're going to do this, and we're going to go, okay, for 3 times, it was 0.432. How about... Oh, was that 1? 0.432. Sorry. Girls, how much whiteout do I have? I'm trying to think 2 steps ahead. I need to slow down. We have a whole double. Okay. How about 0 times? This one here, right? Black, black, black. So that's 0.6 to the 3rd. What's that? 0.2. I have this all just, of course, sitting right in front of me. Okay? So I got that one by getting this, which is 0.6 times 0.6 times 0.6. All right. How about, yeah? Stop me. Michaela, you right? Yeah. Okay. And then 2 is here. All right, 2, we'll do in pink, is 2 white, 2 white, 2 white. .6 for the black, and then 0.4 and 0.4. Do you agree? Probability of 2 whites. .96. Is that right? Oh, times 3. There's 3 of them. 0.288. Okay, so let me just say to you girls, in the world of you doing these problems, these tables are just going to appear out of nowhere. Okay, and you're going to go, where did all those numbers come from? And you can see what we're doing, right? They're not going to make you do this stuff anymore. They're just not going to. It takes too long. They're going to have this there, and you're going to believe that it's right. You get my point? I'm just doing it now to kind of let you know where numbers are coming from. Okay, and this last one is 0.064. It's white, 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 and it's, so it's 0.4 to the 3rd. How come 3 whites is not the same as 3 blacks? Yeah, different probability. There's more blacks in there. Okay, cool. So this thing is called a probability distribution table. It gives you values for little x. What's big X? Big X is, in general, this thing. 0 and you get this. When you put 1 in my function, you get this. When you put 2 in my function, you get that. Okay? Okay, or you can display it on a graph. The number of times I've seen this is very limited, but it's in your syllabus, so let's just put it on quickly one time. 0, 1, 2, 3. So those are all my x values. And then I put my probability values here. And all you do is just graph the dots. Okay, this probability goes up to 2.16. At 1, it goes up to 4.32. At 2, it goes up to 2.88. 3, it goes up to 0.64. Okay, so it's just a little graph. My guess is that they would give you that, and you'd have to figure out that. You know what I mean? I don't think they'd ever make you do that graph. Not sure. Discrete probability function. The following 2 conditions must hold. All the probabilities have to be between 0 and 1. You know that already. Okay, all those little things in the table have to be between 0 and 1. And all those things, there it is, have to add up to 1. So, and one more quick thing. if I'm looking for between, so sometimes they'll say, find the probability that x is between 2 and 4. That means you add up the ones that are between 2 and 4. Okay? We'll go here. So it says, consider the table shown. Does this meet the conditions to be a discrete probability? Totally can see this on a test. Okay? So you go, okay, A, 0.2 plus 0.3 plus 0.1 plus 0.4 equals 1, and all the x's are between 0 and 1. So, yes. All right, that's your little proof.
Wait, when you say all the x's, do you mean like all the...
Oh, all the p of x's. Thank you. All the p of x's. Obviously, all the x's are between 0 and 1. All the p of x's. Thanks, Nina. Then it says, use the table to find the probability that x is greater than or equal to 2. Sorry, misspoke again. So does 2 count?
Yes.
So all of these count. So that is 0.2 plus 0.3 plus 0.1, which is 0.6. Pretty easy. If it just said less than, then I couldn't count the 2. And I'd have to start with the 1. Usually in discrete, like there's an example coming up where they don't do it, but usually it's less than or equal to or greater than or equal to. Cool. Okay. What am I up to? 12 minutes. What do you say we